Welcome! In this video, we're going to look at sine and cos. And so what I want to do is associate for you in your mind the relationship between triangles or right triangles, circles, and then the sine and cos waves. So as the t increases, we're plotting out a sine wave, and you see the y value tracks the y value of that point on the unit circle. Okay, so let's get started. You can see I have my coffee cup here. I think I'll turn it upside down to draw this. So I want to draw a circle, and so let's let this be a unit circle so that we have radius 1. And looks like I got a little bit of coffee on there, but oh well. See how this looks. Okay, so let's put the center there, and then let's draw an x-axis and a y-axis. Okay, there we go. So x and y. All right, and so now I want to start labeling points in steps of pi on 4 radians or 45 degrees. So our first point is the point 1, 0 because we have radius 1. And then my second point is the point 1 on root 2, 1 on root 2, and I want to explain that for you. So here I've got 45 degrees in here, which is pi on 4 radians. And up here I have the same thing. This angle here is pi on 4 radians or 45 degrees. And so if this hypotenuse length is 1 because we have a unit circle, which is the circle x squared plus y squared equals 1, centered about the origin. Now what is this distance from the origin to this point right here? The distance is, well, if you remember, we've got a triangle, right triangle, sides 1, 1, root 2, right? Just using Pythagoras. 1 squared plus 1 squared is 2, and then you take the square root and you've got the square root of 2. Now this is similar to the triangle with sides hypotenuse 1. So what I'm doing here is I'm scaling this, dividing each of the 3 sides by 1 on root 2 so that this becomes 1, and then this becomes 1 on root 2, and this becomes 1 on root 2 also. Okay, and so the distance here is 1 on root 2, and this distance likewise is 1 on root 2. And so that gives us the x-coordinate, the horizontal distance from the y-axis to that point. It tells us that that is 1 on root 2, and hence also, because these are equal, the distance from the x-axis to this point is 1 on root 2 also. Okay, now let's travel another pi on 4 radians counterclockwise to this point. So what is this point? Well, it's the point 0, 1. Okay, and now if we do this again, we end up over here. And so this has the same height as this point over here on the right of the y-axis, but the x-coordinate is minus 1 on root 2. So it's the mirror image of this point about the y-axis. So this point is minus 1 on root 2, 1 on root 2. Okay, and now if we go another pi on 4 radians counterclockwise, we end up over here. This point is easy. We just have -1, 0. Okay, now let's do this again. Go another pi on 4 radians. So we end up here. And so this point is the mirror image of this point about the x-axis. And so we have -1 on root 2, -1 on root 2. Okay, we go another pi on 4 radians from this, and we end up down the bottom at the point 0, -1. Okay, and if we go another pi on 4 radians, we end up here, and that's the mirror image of this point about the x-axis. So we have 1 on root 2, -1 on root 2. And if we go another pi on 4 radians, we end up back here at the point 1, 0, where we started. All right, so now let's think of this in terms of the triangle. How do we get this point? Well, what we have is the x-coordinate is the cosine of pi on 4. Okay, because adjacent over hypotenuse here is 1 on root 2 over 1, which is 1 on root 2. So this is cos of t, and then the y-coordinate is sine of t because that's opposite over 1, opposite over hypotenuse. 1 on root 2 over 1 is 1 on root 2, and that is sine because we've taken opposite over hypotenuse. So sine of t, where t is pi on 4 radians. However, if we take t to be pi on 4 plus pi on 4, which is pi on 2 radians, then we can also use cos of t sine of t to generate the point 0, 1. And so on and so on. If we increase t counterclockwise from t equals 0 in steps of pi on 4, we will get all of these points through the formula cos t sine t. Okay, so now how do I translate this to the sine wave? So if I come down here and plot an axis, x-axis, but I'll, instead of putting x on the x-axis, I'll put t on the x-axis. Okay, and so let's stop at 2 pi radians. Halfway is pi radians. Half of that is pi on 2 radians. And then pi plus pi on 2 is 3 pi on 2 radians. And now if I chop each of these little sections in half, then I have the multiples of pi on 4. So pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, and 7 pi on 4, and 2 pi is 8 pi on 4. Okay, and I could go in the opposite direction also, so this would be minus pi on 4 radians. Now, here is my y-axis. Okay, now the highest the y values go is 1, so I want to put a line horizontally at y equals 1. And the lowest it goes is minus 1. So that would be down the bottom. Something like this at minus 1. All right, now let's just focus on the y-coordinate of each of these points, the y-coordinates. Okay, and so if we focus on the y-coordinates and plot those y values as the angle t changes counterclockwise left to right from the point 1, 0, then we'll get a sine wave. All right, so let's go ahead and do that. When t is equal to 0, y is equal to 0. So we have the point 0, 0 on this graph. And when t is equal to pi on 4, we have the y coordinate is 1 on root 2. Now 1 on root 2 is about 0.7. I'll give you an exact value here. 1 on the square root of 2, 0.7071, and so on. Okay, so that's a little less than 3/4 of the way, and so that might be around here. All right, now when t is 2 pi on 4 radians, we've got the 0.01, but the y value is 1. Okay, so let's put a point. T is equal to pi on 2, and y is equal to 1. Okay, next. When t is equal to 3 pi on 4, that's over here. What's the y value? It's 1 on root 2. And so that is about there. Okay, when t is equal to pi radians, or 4 pi on 4 radians, we have the y value is 0. And so we're back down here. All right, continuing. When the t value is 5 pi on 4 radians, we have a y value of minus 1 on root 2. Okay, so that is down here at about minus 0.7. And then when t is equal to 3 pi on 2 radians, we have a y value that's minus 1. And so that's down here. Okay, and then when t is 7 pi on 4 radians, we have a y value minus 1 on root 2. So something like this. And then when t is 2 pi radians, we have a y value of 0, which is the same y value as where we started. All right, and so now let's connect the dots. When we do, we see this nice sine wave. Okay, and it continues on. It continues down in the negative direction also. All right, so there we have it. Now, if we're to do the same thing with cos, then this is x up here. Okay, if we're looking at cos. And so when we look at cos, we are looking at all of the x coordinates here, right? Because remember, cos is adjacent on hypotenuse, and that's the x coordinates. So let's plot this on the same axis. So the x coordinate, we start off at 1 for x, and then we have 1 on root 2, so we're here, and then we have 0, so we're here, and then we have minus 1 on root 2, so that puts us down here, and then we have minus 1 when t is pi, so down here. Okay, let's start sketching this. And you might do this in a different color, but I think I only have blue. Okay, and then when t is 5 pi on 4, we have minus 1 on root 2, so that's there. And then when t is 3 pi on 2, we have 0, so here. When t is 7 pi on 4, we have 1 on root 2, so that's about here. And then when t is 2 pi, we're back at 1, where we started in that cos wave. Okay, so let's fill in that cosine curve. And there we have it. Okay. And of course it goes in the negative direction too. All right, now you can see that these are shifted by pi on 2 radians. They're out of phase by pi on 2 radians, because if you move this wave over pi on 2 radians, then it coincides with the sine wave. Okay, so now let's do the same thing in Mathematica. So we get a nice plot. So I'm going to start with saying contour plot And I'm going to write in this equation x squared plus y squared equals 1. And let's give this a plot range as x goes from minus 1.1 to 1.1, and then y goes from minus 1.1 to 1.1. I've just given a little bit of extra margin there. Okay, so there we have it. And now let's give this a name. Let's call this A, because I want to show this together with something else. All right, now I want to make a plot of all of those points, and so let's just say we want to tabulate. So let's write table, and then I'll put cos. Now we've gone in multiples of pi on 4. Times an integer k. Okay, so let's do the same thing with sine. Pi on 4 multiplied by k, and then we'll just say k goes from 0 to 8. Let's have a look at our points. Okay, so these are all the points that we've listed out there, right? And so now what I want to do is put these in memory. Let's call this list B. Or actually, you know what? Let's turn this into a plot. Let's just write list plot. All of these points. And we'll just change the plot style. Let's make those red. And let's change the size as well. Okay, and then let's call this B. And then we'll show that on the unit circle. And we'll suppress that A. Okay, so there we go. We have what we have here. It's just we are not showing the values of the points. And so next, I think what I want to do is make another plot. Let's do a parametric plot here. I'm going to give this a name, G, parametric plot. And so I'm going to parametrically plot cos of t, sine of t, but I can see that that letter T is not black. I mean, it's not blue, so it's in memory currently, so I need to clear that. Clear all T. Okay, now let's do this as T goes from 0 to, and I'll just pick a value, 2 pi on 3 for now. But I think I want to change the plot style to change the color. Let's see, plot style. Let's change that color to red. And then we'll show A, B, and G. Okay, so now you can see what happens as I go counterclockwise up to 2 pi on 3 radians with my second plot. Now, but what I want to do here is plot out this, kind of animating this as I go increasing in the value of t. All right, so I'm going to change that 2 pi to the letter lowercase a, and I can see that's in memory, so I'll clear that as well. Now I'm going to get an error. Okay, good, I've got an error, because that's not a specific value. But what I want to do now is write manipulate in front of this. Okay, and I'm going to manipulate that A value as A goes from 0 to 2 pi. All right, so it still complained about this, and I can't see exactly why, but let's just move the bar over. Okay, and you can see what's happening here. The red is traveling along, and it's increasing. All right, let me move this so you can see what happens now. All right, so I'm increasing the t value, and so we're coming around, all right? But what I want to do also is track the y value of this with another plot, because the y value will map out a sine function just like what we have here. All right, and I think this error is because I've just started at 0, so I will start at 0.1 and see if that alleviates that error. Okay, yes, it does, which is fine. I think we can live with that. Okay, good. So now, in order to accommodate a sine wave in the same graph, I think I need to take the value over and, you know, separate, make some more space. And so let's do this. Now, I think to do that, I need to add another 2 to that or so. But let's see what this does. All right, and so I can see it's turned this to make it look a bit more like an ellipse, but that's because the scaling is off, all right? And so let's come up in the y value also, or let's go 1.6. All right, so understand this as a circle. Now I think I can change that with the aspect ratio, so let's try this. Aspect ratio or maybe I need to do this somewhere else rather than in the show. All right, so let's put this here. Okay, there we go. So it looks like a circle now. Now remember what I want to do. I want to plot out a sine wave over here next to it. Create another plot. So we want to plot sine of t. Well, I think this kind of works. I mean, I wanted it to be over to the left a bit, but I think this is probably okay. All right, so now let's make this red at least. So that you see that the height of these things matches, right, as we go across. All right, now let's take this x value out to, say, 2 pi. And try that again. Okay, so as the t increases, we're plotting out a sine wave, and you see the y value tracks the y value of that point on the unit circle, which is what I had hoped for. All right, fantastic, thanks.